everybody, Dori here from D Squared Consulting. So the heart is obviously a really important organ, but in the end, when you're talking about function, everything links back to the brain. The brain is what's controlling the function of those different organs. And so today we're going to talk a little bit about sympathetic versus parasympathetic activity. And when I say sympathetic, I don't mean, caring about somebody else's feelings. I'm talking about your fight or flight mechanism, which is controlled by the brain. And that ends up having an impact on not just your cardiovascular system, but even the progression of particular diseases, including heart failure. So I'll jump into why that is. So you can think of the brain as sort of the regulator of other organ functions, and it has a series of neurons, and those neurons are actually sending signals out to the rest of the body. So the brain is sending signals to the eyes for sight, the brain is sending signals to the lungs to regulate breathing, to the kidneys, obviously to the heart, and each of those organs are also sending signals back to the brain. That's how we're able to see. So let's focus in on the communication between the brain and the heart. And that's done via the autonomic nervous system. And the autonomic system you can think of as the automated functions within your body. You don't have to think about your heart rate. It's just automatically going to be controlled by your brain. So heart rate and blood pressure are controlled by the two competing nervous systems that come from the brain. And that's the sympathetic system, which would increase heart rate and blood pressure. Again, that's your fight or flight, so you have to be ready to take action, or the parasympathetic nervous system, which is what's going to decrease heart rate and blood pressure so that you can rest and digest and things like that. Now, the brain has to have some type of message coming from the heart to know how it's functioning so that it knows how and when to adjust that heart rate and blood pressure. And so one of the ways that the heart sends signals is through what's called baroreceptors. These receptors, which I've drawn in yellow, you can think of as little pressure sensors. So when the heart is ejecting blood from the left ventricle into the aorta, it's going to give those receptors an idea of how much pressure and how much blood is actually flowing out. So really what you're doing is sending a signal to the brain on how well the heart is ejecting, or an idea of that left ventricular ejection fraction. If the heart is not pumping well enough, the brain will then activate the sympathetic nervous system, meaning let's increase the heart rate and increase the blood pressure in order to account for that reduced pumping action. Now, in the short term, that's actually a good thing. The brain has found a way to compensate for the poor function and get blood to the organs that need it by increasing that heart rate and blood pressure. The problem comes in when that increase in sympathetic nervous activity or increased heart rate and blood pressure becomes sustained. So now you have a patient that already has poor heart function and their heart's in overdrive mode. So it's pumping faster, it's working off of more pressure, and that's going to lead to a lot of other problems such as sodium and water retention, which can lead to fluid overload, and all of a sudden you have a patient that's in symptomatic heart failure. So while in general the brain does a pretty good job of managing heart function, if you end up in this overdrive mode, it can lead to the progression of illness in heart failure patients, and that's when you really need a physician to intervene with medical therapy or medical devices. Thanks as always for listening in.